Hello, good morning, friends. The topic for today is logs. So, what is logarithmic? It is a rule which is used to solve algebra. So, we use it to solve algebra, that's all. So, it has an exponential form. Every positive real number, n, can be expressed in the form of n equals to a to the power x. Now, here x, which is the exponent, it belongs to r, real number. So the exponent x belongs to real number. And we have a base called a. So a, the base, should be greater than 0 and a should not be equals to 1. So our base should be greater than 0 and it should not be equals to 1. And n is like greater than 0. That's all. So a logarithmic form is a form. Logarithmic of a number is the exponent by which the base must be raised to that number. So logarithmic of a number is the exponent by which the base must be raised to get that number. So what does it mean? So we have log 10 to the 100. So we need a number on which we will raise the base so that we can get this number. So if we write this question in this form, it would be 100 equals to 10 to the power x. Now we need a number so that we put the power of 10, it would be 100. So here x equals to 2 because we know 10 to the square equals to 100. But before that, I want to discuss the different forms of log. So we have two different forms of log. One is log 10x, which is called the common log. This is known as common log. And the other is log base e to the x, which is known as natural log. And guys, you will see a lot of time in the questions it would be written as ln x. So base e log ex can also be written as ln x. So now I'll discuss some different questions with you how to solve log. So let's have examples. Example 1, log base 264. So this is the question. First we will do is put equals to x and we try to bring it into the exponential form. So what it is, 64 equals to 2 to the power x. So what happens is this 2 goes here and this goes to the power of 2. So we know that x equals to 6. So 2 to the power 6 is 64. Next question is log root 264 equals to x. Now 64 equals to root to the power x. And we know that 64 equals to 2 to the power x by 2. Now this is 2 to the power 6 and this is 2 to the power x by 2. So 6 equals to x by 2. So x equals to 12. I hope it's making the concept clear here. Next question is log of 5, 625. So now we change the base to 5. Now our base is 5. We put it equals to x. 6 to 5 equals to 5 to the power x. Now here we know that 5 to the power 4 equals to 625. So x equals to 4. How it comes? 5 into 5 into 5 into 5. So 5 5 is 25 into 5, 125, 125 into 5 equals to 625. So x equals to 4 is our answer. Now for example, if we have a base which is half and the natural number is 16, we put it equals to x. So what it gives us is 2 to the power minus x equals to 16. Yep. And 2 to the power minus x equals to 2 to the power 4. So minus x equals to 4, so x equals to minus 4. So we got result minus 4. And one more question, then I'll show you what is the pattern. One more example is log 1 to the power 1 by 3, 1 by 9. So here equals to x. So 1 to the power 3 x equals to 1 by 9. Yep. So x equals to 2. So in this page, if we see here, the base was greater than 1, the natural number was greater than 1. We got a positive result. Here the base was less than 1, but the natural number was greater than 1. So we got result in negative. Here the base was also less than 1 and the natural number was also less than 1. We got the positive result. So now I'll show you some important deductions. So important deductions. First is log of n equals to 1. So if the base and the natural number are same, the log will be 1. For example, log of 2 equals to 1. Log of 3 equals to 1. The second is if log of 1 by n to the number n equals to log of n to the 1 by n equals to minus 1. So if the base and the number are in reciprocate, natural number and base are in reciprocate, it will always give minus 1. The third is log of n1 equals to 0. So log of natural number 1 is always equals to 0, irrespective of base. Whatsoever the base you have doesn't matter. If the natural number is 1, the log is always 0. And so next we will go to fundamental identity. Fundamental identity. What it is, if a to the power log an, it gives n. So I have a number which is raised to log and has the same base and has a number, natural number something, it will always give n. For example, 3 log 3 5. So this is 3 raised to logarithmic having a base 3 and natural number 5. It will give the result 5. For example, 2 log 2 7. It will give 7. So this is the fundamental identity of logarithmic. Now, guys, you can make note of this. this will be very useful while you were solving bigger problems. So for example, if log of 2, 4 is equals to 2, it gives a positive number. This is what I was talking about previously when I was showing you when the base and the natural number are either side of 1. So if the base and the natural number both are greater than 1, it will give always a positive number. For example here. The second is if the base and the natural number both are less than 1, it will always give positive result. Third, if the base is greater than 1 but the natural number is less than 1, it will give negative. 2 to the power x equals to 1 by 4 will give x minus 2. X equals to minus 2. So which is negative. The other form could be the base is less than 1, but the natural number is greater than 1. It will also give x equals to minus 2, which is negative. So there are these 4 different ways. So if the base and the natural number is both are greater than 1, positive. If both are less than 1, positive. If one of these is greater than 1 and the other one is less than 1, it will always give negative result. So keep this in mind while solving bigger problems. Next, we will discuss properties of log. This is very important. Whenever you're dealing with complex questions, you need to remember properties of log, and you need to implement these to make those complex problems simpler. So for example, we have log of ax, y. What we can do is we can write it like log ax plus log ay. Here, x is greater than 0, y greater than 0, a greater than 0, and a not equals to 1. So two numbers were in multiply having the same base. We can write them in addition. Log ax plus log ay. And we can, it does not mean like two numbers only. There could be multiple numbers. For example, log ax y z. You can write it log ax plus log ay plus log az. I can show you the example. Example is log of 385 5 plus log of 385 7 plus log of 385 11. This is the question. Now if you see this question, it is in this form. The base are same and the numbers are different, x, y, z. These are x, y, z. So if I can write this in this form, then I can also write this in this form. So what does it mean is log base a, which is 385, x, y, z are in multiply. So 5 into 7 into 11, which would be 385. So log of 385, 385. And we know that log n to n is equals to 1. So the answer is 1. Is this clear? Now the second property is log a m by n. So we can write it as log a m minus log a n. So when the natural number are in multiply, you write in addition. When they are in divide, you write in subtraction. That's the difference. So this is the second property. This is the first property. First, second. Now the third property. Log a m to the power n. Now this n is in the power of m. So you can write it as n log a m. I'll take just an example for it. Let's say log of 11 log 11 1331. So 1331 is what? So first you need to know this thing is also a property. We discussed the fundamental identity. So it will give 1331. So this is log of 11 1331, because we know that 11 raised to the power log 11 1331. We just studied the fundamental property, so it will give 1331. What is 1331? Log of 11 to the power 3. Now this is n, so I can write it as 3 log 11 to the 11. And we know that log n equals to 1, so the answer is 3. So here I use the fundamental identity, 11 raised to the power 11 log 11 1331. So it will give us 1331. We have the base 11, 1331 is 11 to the cube. So here I use this property, n coming here. So n came in front, 3 log 11, and this is what? This is log base n to the number n. So it gives 3. So this question gives 3.